determination of a specific charge is also called E by M. E stands for charge of electron, M stands for mass of electron. So E by M ratio of an electron by Thomson's experiment. Let us consider this experimental setup of J J Thomson. It has got a vacuum tube like this. This is only a schematic diagram where a filament is provided as a cathode, and that is connected to a small battery. And from the filament there be a small perforated plate of cathode that is connected to a high voltage battery, and here an anode plate is kept. This is the cathode, this is the anode, and this is a very small battery, and this is high voltage battery. Here deflecting plates are provided. One is anode, another is cathode. They are called deflecting plates. And we have kept at the right angle a magnet with north and south pole. This south pole of magnet. Here we have fluorescent screen. See, from the heating element, from cathode, it is going through this track, passing through the deflector plate. If there is no current here, that is in this deflection plate, it goes straight. If there is a current and being cathode rays, it gets deflected towards anode. When the poles are interchanged, it goes here. So there will be a deflection. and this is the discharge tube. Overall is discharge tube. And this is the deflection of cathode rays. So the cathode rays are generated from the cathode and they are passed through these deflecting plates whose charges, poles can be changed as plus and minus and vice versa, and also it is getting deflected by the magnetic field. So by the variation of electric and magnetic fields, we are going to find out the specific charge. That is, we are going to find out the specific charge, which is called E by M. That is charge per unit mass. E is equal to charge of electron, M is equal to mass of electron. So this is the experimental setup. Now with the help of this, we are going to study the determination of velocity of cathode rays. Determination of velocity of cathode rays. Since these rays are generated from cathode, they are called cathode rays. Now I am going to blow up this part. Okay. So here the electron is traveling in this direction with the velocity vector v. And this is the electron. It has the negative charge. Now we have kept the cathode and anode plates, that is deflection plates. This is plus, this is minus. So this electron is coming here, and because of the positive charge, it is going to deflect like this, and it is subjected to magnetic field also like this. So here we have kept the magnet with south pole on this side and north pole on the other side. So it is experiencing an electric field as well as magnetic field. So the electric field will be in this direction. So the force experienced by the electron so this is F, the magnetic field, force due to magnetic field, and this is due to electric field, Fe, electric force. And here we have the magnetic field, and here you have electric field. So the electric force balancing the magnetic force, is it not? The electric force is balancing the magnetic force. Fb is electric force, magnetic force. Fe is electric force. E is electron. N is north pole, south pole. Of a magnet. V vector, velocity vector of electron. In fact, the path of electron is a straight line. As we already mentioned, the electric force is equal to the magnetic force. The electric force is given by electric charge and electric field, the product of electric charge and the electric field. Therefore, we can replace this by E and E. And the magnetic force is given by electric charge, magnetic field, and the velocity of electron. So we can equate this with E, B, and B. We know already V is equal to the ratio between the electric field and magnetic field. This should be noted down. This can be striked out. Therefore, V is equal to E by B. So, determination of velocity of cathode rays is obtained. Now let us proceed with the next concept, that is point number 2, that is determination of specific charge. Which is nothing but E by M. V is the potential difference between the anode and cathode. So, potential energy is given as electron volt. And this potential energy is equal to kinetic energy. We know kinetic energy is nothing but half mv square. So E, this is capital V, half m, this is small v square. We know V is equal to E by B, so that can be substituted here. So electron volt is equal to 1 by 2 into m into E squared divided by B squared. And we can bring this m this side, therefore E by m is equal to 1 by 2 into V, then E squared by B squared. By substituting the values of E, E stands for electric field. After all, it is a applied electric field, we know the value. And B is also applied magnetic field, we know the value, experimental value. And V is also applied voltage. So all these values are known. So by substituting these values, we are able to get the value of E by M as 1.7 into 10 power 11 coulomb per kg. Because E coulomb, the unit of charge is coulomb, the unit of mass is kg. So the value is this much, 1.7 into 10 power 11 coulomb per kg. and we can derive the deflection of charge that is only due to uniform electric field. That is the third point here. So deflection of charge only due to uniform electric field. It means we have switched off the magnetic field. B is switched off. Okay. Now the deflection is only due to electric field, right? In that case, the force of electron is equal to E into electric field. We know F is equal to ma. So force of electron is equal to mass of electron into acceleration of electron. Therefore, acceleration of electron can be derived from here, that is nothing but 1 by m into Fe. So acceleration of electron is equal to 1 by mass of electron into force of electron. Now we can substitute the value of Fe, that is nothing but Ee. Therefore Ae is equal to 1 by m into, instead of Fe you can put Ee, right? So in that case, the acceleration is now, we can bring the z this side. So Ae is equal to E by m into electric field. We can isolate like this. Let us study the deviation of path by applying the uniform electric field. This is the electron, the straight path of electron, where we have kept the screen. Now in the middle of the straight path of electron we have kept the deflection plate with positive charge and negative charge, and this is the distance traveled by the electron in the deflection region by electric field, that is the length of plate. So when this electron enters this deflection region, slowly it gets deflected towards anode and goes up here like this. So you can observe a displacement y here. And let us have this electron, assuming that it goes in this way. This is also proportional. Let me put this as y dash. So this is the deviation. We are studying actually the deviation of paths of electron. Electron means this cathode ray. By applying uniform electric field E. And what is Y here? The deviation produced from original position. On the screen. Being fluorescent screen, we can look out the spot created on the luminescent screen by the electron. So initially the upward velocity will be 0, is it not? So let me put u at this stage. So u is equal to 0. What is this u? Initial upward velocity of electron, right, before entering the parallel plate. Before entering the parallel plate. Plates. Now T is the time taken by the cathode rays to travel. You can either call cathode rays or electron here. So T, time taken by the cathode rays to travel in electric field. And we know L is the length of the plate. Length of the deflection plate. We know S is equal to Vt. S means displacement. Here L is equal to velocity into time. So from this, time can be calculated, which is nothing but L by V. We have an equation S is equal to ut plus half at squared. So we are talking about this upward displacement, so that can be interpreted as y here, is it not? So y dash instead of s, and u is already 0 into t plus half a t square. So a is here electron acceleration and t square. Therefore y dash is equal to 1 by 2 into AE, acceleration of electron, into t square, that is 1 by 2 into, we have already the acceleration of electron as E by m into E. We can replace this, is it not? So instead of this one you can put E by m into V. Got it? E. It is E. So E by m into E, and then t square. T is nothing but L by V. So L by V whole square, and this is velocity, right? So we have now these terms instead of y dash. Okay. And we have another equation, that is V is equal to E by V. Is it not? We have mentioned about this velocity, correct? V is equal to E by V. So this is also replaced. Excuse me. V is equal to E by V. So we will replace this one also. Therefore, y dash is equal to 1 by 2 into E by m into E into L squared into, instead of 1 by V, we can put B by E whole square. This y dash is equal to, now we can cancel this E and E square. Therefore, y dash is equal to 1 by 2 into E by m into L squared B squared divided by E. In fact, the deflection y on the screen is proportional to y dash. So we can introduce the proportionality constant C. So y is equal to Cy dash. Now we can substitute the value of y dash. So C into 1 by 2 into E by m L squared B squared divided by E, that is equal to y. Now we can suitably rearrange. We want this E by m. So E by m is equal to, we can bring everything this to this side. So y into E, is it not? Y into E into 2 divided by C L squared B squared. Okay. Now y is the experimental value, that is the displacement noticed on the screen. E is the electric field, that is the applied one. B is the magnetic field, and L is the experimental value, that is the distance of the, or the length of the plate. C is the proportionality constant. By knowing all these values, we can calculate E by M as 1 by 7, 1.7 into 10 power 11 coulomb per kg. So this is the value of specific charge of electron. Now you should note down one important one. See, these are all constants only, the applied fields only. And in fact, you should know the E by M is independent of the gas used, because inside the discharge tube we use the gas, and it doesn't depend on the nature of the electrodes. Since Y is after all the experimental value, E is electric field applied value, B, all these are all constants only, the observed conditions. Therefore, E by M is the constant, and that is declared as 1.7 into 10 power 11 coulomb per kg by J J Thomson.